What does this word mean? Multiple numbers or terms, right? Multiple numbers or terms. So I need to be able to use some words today that you know what I'm talking about without having to define them every single time I say them. So can we talk about that right now? For example, what specific name do you think this polynomial has? Well, how many terms are there? 2. So what do you think it might be called? Binomial. A double nomial is close, but it's not quite right. A deuce nomial, which is what they guessed last period, also close, but not quite right. Binomial. What do you think? Trinomial. Wait, why is this called a binomial? It has 2 terms. And why is this called a trinomial? 3 terms. Everybody okay with me being able to use that vocabulary today in class? Okay. So, here's where we'll start. What is the greatest common factor most commonly referred to as? GCF. May I call it GCF, or do I need to call it greatest common factor? GCF is good? So, last week, what did we do in relation to polynomials? We multiplied, we divided, we added and subtracted, right? Okay? Now guys, most of your life you've been told that the opposite of multiplying is dividing. Well, because that's true, okay? But when we're talking about polynomials, there's another thing that we can do instead of quote-unquote dividing that's also breaking it down into its parts. And that's called factoring. It's my second favorite F word. Next to fractions. What are you thinking about, weirdos? We got to factor. Today I'm going to teach you how to factor, okay? And in fact, we're going to spend all week factoring. Is it because it's that hard? No. It's because there's a lot of little things that you have to look at, a lot of little pieces and parts, okay? And I want to make sure that we're good at it, because once we're done with factoring, you think we'll ever see it again in Algebra 2? At least 3 more times. So I would like us to get a really firm base of it now, so that when we get to the next time, and the next time, and the next time, you're like, oh yeah, factoring. I love factoring. It's my second favorite F word. Okay? Some people said it's their second favorite F word to fudge, because fudge is delicious. Okay? And some other people said it was their second favorite F word next to friends, because they love their friends. Family is also a good one. That's a good one. Oh, food is even better. Okay, so let's talk about GCF. Let's talk about greatest common factor. If I give you a trinomial, or any sort of polynomial, it doesn't have to be a trinomial, but let's talk about a trinomial right now. 2x to the third, except can I make that a second? Because that's what I meant to write. 2x squared plus 6x plus 8. Does this polynomial, in this case trinomial, have a greatest common factor? Is each term all divisible by the same number? What is that number? Okay, so the 2 doesn't just go away. We don't just ignore it. We actually factor it out front. We pull it out front. We are dividing each term by 2. So is factoring kind of like dividing? Yes, we're breaking it into its parts. Okay? What's left if I divide this first term by 2? X squared. What's left if I divide the second term by 2? 3x. And what's left if I divide the last term by 2? 4. Done. That's the answer. because all I'm asking for is greatest common factor right now. We might be able to go further later, but not right now. Is that fair? But for the record, you can't go further than this one on that one. You okay? Okay. What if I give you this binomial? Does it have a greatest common factor? 4x squared. Wait, so I can factor out an x if I want to? Okay, it just has to be something they're both divisible by, right? They are both divisible by a 4, but they're also both divisible by an x squared. So if I factor out a 4x squared, what is left? From this first term, if I divide a 4x squared, what's left? X squared. And what's left from this term? Plus 2. Done. Any questions? Okay. So, let's talk about this problem right here. What type of polynomial is this? It is a binomial. That is important. Does it have a greatest common factor? It does not. Okay. What do you notice about this binomial? What sign is in between the two terms? What do you notice about each one of these terms? Are they special in any way? Yes, it is the difference of squares. I need to make sure you understand what both of those words mean. You figured out the difference pretty quickly, right? It's the difference because they are subtracted. Squares. What does a term mean to be a squared term? Okay, so the first term, it's pretty obvious that it's a squared because there's a 2. But there's not a 2 in this number. But it's still a squared. So 49 would be okay to be here. 25 would be okay to be here. 100 would be okay to be here. 64, 81. Anything that can be square rooted, right? It's called a squared because it's a squared number. It's a number that's something times itself. That's a squared number. Okay? If you recognize something as a difference of squares, I would like to teach you a pattern of how to get the answer to this problem. Can I do that? Here's the pattern. Binomial, binomial. Now, you don't have to draw the lines if you don't want to. I'm just making sure we understand that these are two binomials. What do you think might go in the first term of each binomial? X. Why would I put an X in the first term of each binomial? That is x squared. Sorry, the square root of x squared. What do you think goes in the last term of each binomial? A 4. What am I missing? Signs. Okay? This is an important pattern to remember. What's true about them? They're opposite. Can I try to trick you? Well, I'm going to anyways. What if I wrote this instead? Which one of these two answers is correct? Is it this one correct or is this one correct? It doesn't matter what order you multiply in, does it? Isn't A times B the same thing as B times A? I still get the same answer, right? If I said 2 times 3, what do I get? 6. If I said 3 times 2, what do I get? It does not matter what order I multiply in. So I could put x plus 4 times x minus 4, or I could put x minus 4 times x plus 4. Do you understand? Either one of these answers is correct. And that is the answer. Okay? So what if the problem was 25x squared minus 36? How would I factor this difference of squares? 5x minus 6. 5x plus 6. Done. What do you think? I forgot to tell you I'm trying to trick you. What do we always look for first when we're factoring? Greatest common factor. Does this problem have a greatest common factor? What is it? 25, right? If I factor out a 25 from each term, what do I have left? 4x squared minus 1. Is this still the difference of squares? Is 4 a squared number? Yes. What is its root? 2. Is 1 a squared number? Yes. What is its root? 1. Now go to the answer then. What do I do with the 25? Drag it along. What are my two binomials? Two x minus 1, 2x plus 1. This whole thing right there is the answer. Can I try to trick you again? Okay. What you got? Some of you are giving me strange looks. Why are you giving me strange looks? Oh, these are big numbers? So he's looking at me and saying, we can't do this. Why can't we do this? Guys, is this the difference of squares? It's not, is it? This is not the difference of squares at all. What is it? That's the sum of squares. Here's the really good part about the sum of squares. Yeah, everything changes. It's super easy because you can't do it. Why did I write prime? What does prime mean again? It's only divisible by 1 and itself. Okay? It cannot be factored, so we write prime. Sum of squares is prime. Difference of squares we can factor, and we should. Okay? Sum of squares, that's prime, and we can't factor it. Got it? So when you go to prime time, you should not be factoring. Can't factor at prime time because it's prime. That was just a little math joke. That's fine. Okay? Have you been tricked enough already today? Okay, well, too bad. I'm going to try again. What do you think? It's the difference of what? Do you think we factor it exactly the same way? No, we don't, but it has its own pattern. Are you ready for the pattern? Binomial, trinomial. What do you think goes in the binomial? What's your guess? X and which would be what? So X and 2. That's correct. Where did we get those two numbers again? Somebody else who then actually said the answer. Somebody else tell me where this X came from. Cube root of this first term. I wrote it here. Where did this one come from? Cube root of the second term. Okay so far? Can I show you the pattern for the trinomial? For the record, for the trinomial, I don't look back to the original problem. I look back to the binomial, the thing that I already have written down. Okay? For the first number, I square the first number in the binomial. What do I get? X squared. For the last number in the trinomial, I square the last number in the binomial. For the middle number of the trinomial, I just multiply those two together. 2x. So what am I missing? The signs. Watch the pattern for the signs. Watch and then write. What's the sign in the problem? Then that's the sign that goes here. The next sign is opposite of that. The last sign is always plus. Got it? The sign in the binomial is the sign of the problem. The next sign is opposite of the first sign. The last sign is always plus. Okay? What about this one? What do you recognize it as? What's it called? Difference of cubes. If it's a difference of cubes, I get a binomial and a trinomial. Okay? What goes in the first term of the binomial? The cube root of the first term, which is, try again, 3x. What times itself equals 27? 3. Right? 3 times 3 is 9, times 3 is 27. Does everybody understand that? Okay. What goes in the second term of the binomial? Cube root of the second term, which is? Five. Yes, that's correct. After I wrote it. You did it. Okay. How do we fill in the trinomial? So square this one. 9x squared. Where do you get the middle term? Multiply them together. 15x. And where do you get the last term? Square it, which is 25. What are the signs? Same as the problem. Opposite of that, always plus. Can I answer that question in just a moment? Let's do this problem first, and I think that will answer your question. Wait a minute. What do you recognize this as? This is the sum of cubes. What you need to know about the sum of cubes is that it can be factored. But the thing is you already know how to do it because I just taught you the pattern. I haven't shown you any formulas yet, have I? There's formulas for all of these. I haven't shown you any formulas. I've shown you patterns. Okay? If I've shown you patterns and you know the pattern for the sum of squares, what do you get? A binomial and a trinomial. What goes in the binomial if I'm factoring the sum of cubes? which is 4x. What goes in the second term of the binomial? Which is 1. Somebody else, how do I fill in the trinomial? Square the first one, which is 16x. Somebody else, tell me the middle term. Oh, excuse me. Pardon. 1,000 pardons. What goes in the middle term? 4x, because I multiplied 4x times 1 and got 4x. What goes in the last term of the trinomial? Square the second term. What is it? 1. Now for the signs, and this will answer your question. You ready? What goes first? Because it's the sign of the problem, right? What goes next? The opposite of that. And what goes last? Always plus. Does that answer your question? Good. Any questions so far? If I give you the difference of squares, could you factor it? If I give you the sum of squares, could you factor it? Yes, by writing prime. If I give you the difference of cubes, can you factor it? Sum of cubes, can you factor it? So what's true about all of these 4 that I just showed you is that they are all binomials. Every single one of them. Right? Even this one that I tried to trick you on, that we had a greatest common factor that we had to take out first. It was still a binomial, wasn't it? Okay? So what happens if it's not a binomial? Is that going to be a possibility? I'm just going to start off as easy as I possibly can. What? Oh, here's a good trick question. What kind of polynomial is this? What do you think? Guesses? You ready? It's called a polynomial. Yeah. Binomial, trinomial have terms. Beyond that, we just call it a polynomial. It might technically have a term, and if it did, I would probably say it's something to do with quad. Okay? But we're just going to call it a polynomial. You ready? Here's what we do for 4 terms. We call this factoring by grouping. Okay, we're going to factor this by grouping, which means I'm going to group this polynomial into binomials because I'm really good at factoring binomials. If we just look at the first 2 terms, does it have a greatest common factor? What is it? X squared, right? Both of those terms are divisible by x squared, right? If I factor out an x squared from each term, from just the first 2 terms, what do I have left? X plus 1. Yes? Now ignore that part and just look at the last 2 terms. What do these 2 terms have in common? Knowing that I have to take something out. Page 1. They're both divisible by 1. If I divide x by 1, what do I get? If I divide 1 by 1, what do I get? 1. Now when I look at what I actually have, here's what I need you to notice. I'm going to call this 1 term, and I'm going to call this 1 term. That may or may not be entirely mathematically accurate, but can you go with me for just a second? Do these 2 terms have something in common? What do they have in common? So do they have a common factor? Yes, then factor it out. If I divide an x minus 1 from each term, what's left from the first term? X squared. What's left in the second term? 1. Done. I just did not magic, but mathemagic. Boom. Boom. Should I do another one like that? Okay. That's supposed to be a 2. 3x minus. Just look at the first two terms. What do they have in common? 2x squared, right? What do I have left if I divide this term by 2x squared? If I factor out a 2x squared, what's left? X, and this one? Minus 3, right? Look at the last two terms. What do they have in common? A 3. What's left if I factor out a 3 from this term? And this term? Minus 3. Do these two terms have something in common? What factor do they have in common? X minus 3. What is left from the first term if I factor in x minus 3? 2x squared. And from the second term? Plus 3. Done. Guys, is there any reason that you should get any of these wrong? Is there a way to check them? Yeah, couldn't I just multiply back out? 2x to the third plus 3x minus 6x squared minus 9. Now that's not exactly in the same order as the problem was given to you, but isn't that still the same answer? Yeah. Any questions? Sometimes you have to be careful. Okay? Oops. I need that to be a minus. Sorry. That's a 3. That's a 2. That's a 1. I can't math today very well. I apologize. Can I change this to be a 6? Okay. I think that's what I want it to be. So 4x to the third minus 2x squared minus 6x plus 3. What do the first two terms have in common? 2x squared. What's left if I divide the first term by 2x squared? 2x. And the second term? Minus 1. What about the second two terms? A 3. Guys, if I factor out a 3, did you notice that what has to happen is these two are the same? If I just factor out a 3, are they going to be the same? What do I need to factor out then? How about a negative 3? Do you see? Kind of takes some thought ahead of time, right? Some forethought. So if I factor out a negative 3, what do I have left? A positive 2x. And if I factor out a negative 3 from here, I'm left with a negative 1. Now are they the same like they need to be? So if I factor out a 2x minus 1 from each, what I have left is a 2x squared minus 3. You okay with that? Any questions about factoring by grouping? That's what this is called. When there's 4 terms, we factor by grouping. Any questions about sum and difference of cubes? Any questions about sum and difference of squares? Any questions about greatest common factors? Okay, go ahead and get to work on your homework.